Okay. Hi, good morning. Just let me know if I'm audible. Let me know if I'm audible so that we can start up. This is our third session of gravitation. So just let me know in the chat box if everything is fine so that we can start. Mm, can we start? Okay, I think everything is audible and everything, right? Okay, so okay, fine. So we can start. We can start. There is no issue. So what we had seen last time was we had covered some basic the topics. You already know that there are many of the topics which have been deleted from the syllabus. So you don't have thrust and pressure, you don't have Archimedes principle, and you don't have relative density. So three topics you don't have in your syllabus, but the rest of the things are there. And we have already gone through many of the basic formulas, like for example gravitation, free fall. Last time we had seen, and we were about to go for what exactly how we calculate the value of g and does it remain same or not. We have to talk about this. So can we start? Okay, so last time what we had seen was let me take a blank slide first and then we'll talk about it. Okay, so what I want to tell you is कि last time we were able to derive one formula for acceleration due to gravity, and that is g is equal to capital G into capital M divided by d square, wherein we had replaced there are standard values. G is nothing but the value of basically gravitational constant. So this is a very much a value which you already know. M is nothing but mass of earth. Let me just write down what those values represent. So this particular G is nothing but gravitational constant which remains same throughout the universe. This is gravitational constant. It has a standard value, doesn't change. It is same for earth, it is same for Mars, it is same for sun, it is same for everybody. Now what about M? M is nothing but mass of earth. Mass of earth. Okay. What about D? D is nothing but radius of the earth. Radius of earth. In this case, it is radius of earth. In this case. Okay. So we have talked about this in detail last time. Now what we'll be doing is, you just have to tell me one thing. Just one thing. Can I say, suppose let us say, if I am writing down two formulas, same two formulas. G is equal to capital G, capital M divided by d square. And there is another formula that is small g is equal to capital G, capital M divided by d square. Don't you think that, suppose let's say if I want to find out for earth, then I have to take the value of M of earth, that means mass of earth. This is what we had taken, and the radius also was taken of earth itself. Okay, but what if the acceleration due to gravity we need to calculate is for the planet Mars, or it is for the planet suppose let's say Jupiter, or whether it is for the moon? So how can we change the values then? So for example, if you want to find out the acceleration due to gravity on Jupiter, or suppose let's say Saturn, let us take a simple Mars, because it has just 4 letters, so we can just put Mars here. So if you want to find out G value of Mars, you need to know the mass of that planet, that is Mars. You need to know what is the mass of that particular planet, and you need to know what is the radius of Mars. So can I say, but mass of earth and radius of earth, that will always be different. Radius of earth and radius of Mars will be different. Mass of earth and mass of Mars will be different. Both will be different. So can I just say G of earth is not equal to G of Mars? That means the value of G is not same for earth and it is not same for Mars. They are not equal. They will be changing. Okay. So can we say, in short, we can draw two conclusions from this. Acceleration due to gravity that is small g changes from place to place. Agreed? Changes from, matlab like planet to planet, you can say for now, you can just say for now it is changes from planet to planet. Planet to planet. Okay, and what about capital G, gravitational constant? That doesn't change. That is going to remain same no matter what. Let me just highlight it for you. This is the value we are talking about. Value of G is always going to remain same. No matter what, it will remain same on Earth. It will remain same on Mars also. So capital G, gravitational constant, it is same for gravitational constant. It is same for all planets. Same for all planets. Are you understanding this? It is same for all planets. Okay, I hope the point is clear that gravitational constant is same for all the planets. Now, can we do one thing? Can we have distinguishing table for both of them? Can we have a distinguishing table? It will become more clearer then. Correct? Okay, so let me just draw a table and we will just write down 2 or 3 points regarding the difference between gravitational constant and acceleration due to gravity. Okay, so let me just write down the names. The first name is acceleration due to gravity. Acceleration due to gravity. Okay, what is the value, or suppose let's say letter we use to denote it? It is small g. And what about gravitational constant? That is capital G. We denote gravitational constant by capital G. Gravitational constant. Okay, so that is what we have written till now. Okay, now let us let us try to write down the difference between both of them. For the first difference, we will say acceleration due to gravity is nothing but acceleration due to Earth, right? It is acceleration due to Earth during free fall. During free fall. This you already know. Acceleration due to gravity during free fall is nothing but called as acceleration due to gravity, correct? Or in short, you can say acceleration provided by the Earth is nothing but called as acceleration due to gravity. In simple terms, acceleration provided by Earth is called as acceleration due to gravity. What about gravitational constant? Gravitational constant is very much different. It is nothing but a constant value used in the formula, okay? Nothing but just a constant value used in the formula, that is gravitational formula. What about suppose let us say in terms of the units, what is their unit? Unit for acceleration due to gravity, this one small g, is meter per second square. Why meter per second square? Because it is acceleration, so unit would be meter per second square. What about gravitational constant? Gravitational constant will have different unit. The unit is very much different, that is Newton meter square. We have already seen this, so we are just going to write it down. Unit for basically your gravitational constant, what is the unit? Newton meter square per kg square. The unit is completely different. Unit for this is different. This is very much different. What about the change in value? Do they change? Do they change from place to place? Yes. Gravitational constant doesn't change from place to place. Doesn't change from place to place. But acceleration due to gravity, yes. Acceleration due to gravity changes from place to place. It changes from place to place. Agreed? Just write down in the chat box whether you are understanding the difference. That acceleration due to gravity, suppose let's say is changing, suppose let's say during the fall, and the gravitational constant is just a constant value in the formula. Unit is already written. It changes from place to place, that is also we have written. Let us write down their standard values also. Standard values. Standard value for acceleration due to gravity is 9.8 meter per second square, right? Value. And what about value of capital G? That is 6. Can somebody please write down the value of capital G in the chat section? In the comment section, just write down what is the value of G, capital G. I want the value of capital G. Just write it down in the chat box. 6.67. Okay, 6.67 into 10 to the power minus 11. Agreed? 6.67 into 10 to the power minus 11 Newton meter square per kg square. Agreed? Just write down in the chat box whether the value is fine with you. Okay, so we have written our value. We have written our value, and now we are going to close the box, right? Yes. And one more point you can definitely add, and that is about the way they are denoted. The way they are denoted, that you can definitely add. You can just write down. It can be denoted by. It is denoted by. It is denoted by G. Take a small g. Okay. And another thing you can write down is it is denoted by capital G. It is denoted by capital G. So we have gone through the difference between the two. Fine. We have gone through the difference between both of them. Now can we move on? Can we move? Because we have already seen the difference. Now we can go on. Now major factor we are going to learn today is how can we calculate the value of G as 9.8. Okay, how can we really calculate? So the way we can calculate is very simple. Okay, so for calculating the value of G on earth, if you want to calculate the value of G on earth, you can just simply put it in the formula. Formula is small g is equals to capital G into capital M divided by d square. Okay, you just have to put the values, standard values in this particular formula, and you will get your answer. But value of G is constant, that is already known to us, so there is no point in discussing that value. Okay, mass of earth, this is mass of earth and this is the radius of earth. That should be known, that should be known. So that's a standard value. What is the mass of earth? Mass of earth is equal to 6 into 10 to the power 24. 6 into 10 to the power 24. And what about radius? Radius value is, radius of earth, that is distance, you can say, is equals to 6.4 into 10 to the power 6 meters. Okay, and this is kg. Okay, so mass of earth is 6 into 10 to the power 24 kg and radius of earth is 6.4 into 10 to the power 6 meter. That's it. You just have to put these values in the formula and you will get your answer. Okay? So how to write this in the exam? How to, suppose, let's say, write down this thing into exam. So let me show you how it is done. We will use this slide. No, this is already occupied. Okay, we can use this one. Chalo, let us write down. So let us write down the formula first and then we'll put the values and we'll calculate the answer. So value of G we need to calculate on earth. Formula is capital G into capital M divided by d square. So d square can be written as r square because it is the radius of the earth. So we can just write down r square, correct? Okay. Now let us put the values there. Let us put the standard values. And let us denote that radius by capital R because that is the radius of earth. So we can just denote it by capital R. For our understanding, it doesn't matter even if you take it small, it doesn't matter. You just need to remember that it is the radius of earth, nothing more. Now the value of values for these variables we will write down and then we'll put it in the formula. Capital G value is 6.67 into 10 to the power minus 11. Okay. What about M value? M value is just we had seen right now 6 into 10 to the power 24 kg, correct? And what about the value of R? Value of R is 6.4 into 10 to the power 6 meters. These are the standard values. You just have to put all of them into which formula? Into the above formula. Okay, just put it there and you can just write down. In the exam also you have to write down the same thing. In the exam you have to write down the same thing. 6.67 into 10 to the power minus 11 into M value is 6 into 10 to the power 24. After that, value of R, that is 6.4 into 10 to the power 6 and square. The square value has to be done. Now once you have put all the values, you don't have to calculate. You don't have to calculate because even if you calculate, you are going to get the same answer, and that is 9.8. Just let me show you how exactly. See, problem is that many of the students try to do that calculation, but you don't need to do it. You don't need to do it. After calculating all of that, you are going to get the answer as 9.8. So once you write down the formula, that is the first step. Put the values, second step. Third step, directly write down the answer, that is 9.8. In the exam, you don't have to show the actual calculations. You are supposed to write down after this step just 9.8. You just have to write down 9.8 in the exam, that's it. because that calculation even if you do, you don't have to waste time in that. There is no necessity. You can just write down the values, put that number, you will get your answer. That's it. So you write down the formula, then put the values, and then write down the value as 9.8. So just tell me in the comment section, are you understanding this, what to do, and so let's say how to manage this. Write down the formula, put the values, and write down 9.8. Are you understanding this? So let me understand, suppose whether you have completely assimilated this topic, that how to write down in the exam, which values to put, and how to calculate the answer. Write it in the comment section whether you are really understood how to write down all of this. Okay, fine. Now let us talk about moon. Because many of the times they are going to ask you, suppose let's say acceleration due to gravity on moon, or suppose let's say earth. So these values, earth values you have to remember. You have to recite. Let me tell you which values you have to recite and which to not. So earth value has to be remembered. Mass of earth is nothing but 6 into 10 to the power 24 kg. That has to be memorized. And radius of earth, and that is nothing but 6.4 into 10 to the power 6, right? That we already know, and that is in meters. But that's a non-standard value. Your actual value is this one. You can see there is a little difference. We have taken 6. The actual value is 5.98, but we have made it 6 for our calculation, so that our calculations become easier. So that's why we have taken 5.98 as 6. And radius of earth is also 6.4 into 10 to the power 6. The actual value is 6.37, but we have made it 6.40. Doesn't matter. That's just a small difference. So ignore these values, ignore both of them. You just have to talk about these values, nothing more. Understood? Okay. Now in the exam, you just have to remember of earth itself. You don't have to remember radius and mass of every celestial body. It is not possible to remember mass and radius of each body, that is Mercury, Venus, then Sun also, other planets also. There are lakhs and lakhs of planets, so it is not possible to remember mass and radius of each planet. So if a question is asked in the exam regarding calculations and all, they will give you the values. And then they will expect that you please calculate. Are you understanding how the question is going to be coming in the exam? They won't be asking any specific value regarding any of the planets. You will be given the value of mass, you will be given the value of radius. They are not going to ask you, suppose let's say the mass of a particular planet, you don't have to remember. The only values you need to remember is of earth. Once you remember of earth, other things are not suppose let's say necessary. You can just ignore both of them. Fine? Okay. Now can we move ahead? Okay. Now let us try to understand how can we find out the values of, suppose let us say, on moon. But before we get inside it, we have to find out and talk about what is the difference between mass and what is the difference between weight. What exactly is mass and what is exactly weight? So let us discuss about this. So for that discussion, we will require a fresh slide. Now let us talk about mass. What exactly is mass? Let us talk about this. Okay. Kushal Jain, you know that, right? Unless and until I complete all the theory, I won't be able to take the numericals, right? That is our usual practice, that we first take theory and then we take numericals. So that is the same thing we are going to follow for this lesson as well. We are not going to change our pattern for this lesson. Fine, Kushal. We'll be taking numericals once our theory part is done. Once our theory is complete, then we'll move on to numericals. Now let us talk about our mass exactly. What exactly is mass? So mass is nothing but the material content of the body. Basically, it is measured in kg. And that is nothing but the material quantity. Now you already know your body is made up of matter. It is composed of particles, and it has certain particles inside you. So that means mass is nothing but the material content inside the body. The material content. inside the body. Okay. Now question is, what is the unit we use for measuring mass? Mass is nothing but the material content inside the body, and how do we measure it? We measure it with the help of kg. The unit we use for measuring this kind of material content is kg. Unit is kg. Now question is it going to remain same on earth? Is it going to change on, suppose let's say, moon? For example, if there is a person named Suresh, for example, Suresh has, suppose let's say, his mass on earth is let us just say 30 kg. Okay, it's 30 kg. Now what is the meaning? Whether his mass is going to change on another planets. For example, if he goes to Mars, what is going to be its mass basically? So if he goes to Mars, his mass is going to remain same, that is 30 kg. What if he goes to Jupiter? Even if he goes to Jupiter, his mass is going to remain same, that is 30 kg. So that means mass is universally constant. Wherever you go, it doesn't matter to which planet you are going, to which place you are going, your mass is going to remain same. So it has a constant value. Mass has a constant value. Okay? So mass is nothing but material content inside the body. Its unit is kg, and it has a constant value. It is not going to change from place to place. Now let us talk about force. What exactly is force? Let us talk about that. Okay, so for force, basically your weight is nothing but a force. Weight is nothing but a kind of force. It is basically a kind of force. Now how can we calculate this force? Because this is related to gravity. This force is related to gravity. Correct? Now so that means the only way we can represent this formula is with the help of gravitational formula. Whatever the Newton has given, the same formula we have to use in our calculations. Correct? Okay. Now question is, how can we use it? How can we really use it? So we have already been given in many of the suppose let's say derivations in our book, but let me show you a very simple technique how to use that weight thing. Now already you know what is the formula for weight. So weight can be calculated, suppose let's say the value of force exactly. So force can be calculated with the help of okay. So what is the formula for force in gravitation? Force is equal to capital G into capital M divided by small m divided by r square. Now why these changes have been made? What is capital M, what is small m, and what is r? Okay, so we are trying to calculate the force experienced by the body on earth. Okay, so that is what we are trying to calculate. Force experienced by the body on earth. Okay, so what is capital M? Capital M is nothing but mass of earth. So basically that is mass of earth. Okay, what about M? Small m is nothing but mass of the body for which you are trying to calculate the weight. So that is mass of body. Okay, what about R? That is radius, basically the distance between the body and the earth, center of the earth. So that is the radius of the earth. Okay, can we say that they are trying to calculate basically force, but this force is nothing but what special name we have given for it? This gravitational force we are talking about. What is the special name we have given? We are saying it is weight. So can we say that W is equal to F? W is equal to F because we have given this force a special name, that is weight. So that means W is equal to F. W is equal to F. Weight is equal to F. So hence F can be replaced by capital G, capital M, small m divided by r square. Okay. So can we just change that? Can you see this part? Suppose let's say capital G, capital M, and r square. Don't you think this has a value we have recently calculated, that is 9.8? That has the value of 9.8. That is what we know. Correct? Okay. What about M? M is nothing but just a value there, and that is W. Correct? Okay. So that is the same formula. Force is equal to mass into acceleration. Don't you think? That is the same formula we are actually trying to get. So that means our weight is nothing but a force. Weight is nothing but a force, and that is which force? We are gravitational force. That is what we are talking about, and we can differ about mass and weight in the next session. So let us just revise what we have said. Mass is nothing but the material content inside the body, and what is weight? Weight is nothing but the gravitational force which is experienced by the body. So weight is force, mass is just a material content. Let us just write down some 2 points and then we'll end our session. Mass is material content, right? Material content. Okay. And what about weight? Weight is force. But is it any kind of force, or it has a special name? It has a special name, right? That is gravitational force we are talking about. Gravitational force. Okay. So what are the units? This is represented by M. This is represented by W. What are the units? Unit for this is kg. Unit for this is Newton. Why Newton? Because it's a force, no? It's a kind of force, so that's why the unit is Newton. Okay. So are you understanding the basic difference between both of them? Mass is material content, weight is gravitational force. Mass is represented by M, weight is represented by capital W. Unit for both of them, mass unit is kg and unit for weight is Newton. So that is what we have understood till now. But in the next session, that is at the period of 11:40, we'll be having next period at 11:40, right? So I will explain all of this again. The basic difference between mass and weight, and then we'll continue our discussion. Fine. At 11:40 we will again have a class today itself, and I will again explain you the difference between mass and weight, and we'll continue. So thank you so much for now. We'll be meeting at 11:40 for the next period. Thank you so much. The link will be posted in the group, and we'll talk about this at 11:40. Okay? So thank you so much. Bye bye.